So in the last class, we have done one colligative property that is called the relative lowering in vapor pressure. So there we have explained and mathematically proved also that lowering in vapor pressure is a colligative property. Today we are going to do the second one is is elevation in boiling, elevation in boiling. Okay, see here. What do we mean by elevation in boiling point? What is boiling point? We know it is the temperature at which the boiling, the vapor pressure of a solution becomes equal to atmospheric pressure. Again, from Raoult's law, what did you learn? We have learned that the vapor pressure of pure solvent is more than that of the solution. Reasons I have already told you. Because in solution, some solute particles occupy the space occupy the space in the upper layer. So the less amount of solvent evaporates. If the evaporation is less, vapor pressure should be less. So if you wish the solution should boil, you have to generate enough vapor so that it should become equal to atmospheric pressure. All right. To generate enough vapor, then you have to heat it. When you heat, the temperature of the solution goes up. So that difference between the boiling point of pure solvent and the boiling point of the solution, that difference is called elevation in boiling point. You can try in your home, you will find, say you want to make some cup of tea, say you want to make red tea. So you take same amount of water in both container and put it on the flame. In one of this container, put only water, and another container to that you add sugar because we have to add sugar. Hmm. So in that case, you will find কিন্তু গভর্নমেন্ট কিন্তু বলেছে না যেতে তোমাকে বলে রাখলাম কিন্তু কথা শুনবে না যাও so the difference between the boiling point of the solution and the pure solvent is called elevation in boiling. So already I have the note is being given to you. You can read this word from the note. Now I'm directly coming to the reaction. It has been observed that the sorry, just I've done little. How did you observe? So that should write there. It has been experimentally observed that elevation in boiling point of a solution containing non-volatile solute. যে বিপদটা ডেকে আনবে না বলে দিলাম তুমি সব বুঝো নন ভোলাটাইল সলিউট is directly proportional to the molality molality means what? Is the strength of the system. That is the amount of substance that is present in the system. Okay, now see if TB0 and TB are the boiling point of TB and TB0 are the boiling point of pure solvent and solution I did not write yet. I'll write yet. What did you find here? Which is more? You will find here that as for pure solvent, vapor pressure is more. So in that case, you will find it is going to boil early. Here, vapor pressure is less. So you have to heat more to boil it. So this value is more than this. Where TB is greater than TB0. Okay. Therefore, difference in boiling point, that is delta PB. I will not write difference here. Elevation in boiling point delta TB is equal to what? Which is greater? This is greater. TB minus. What did you learn from there? What does it say here? It has been experimentally observed that the elevation in boiling point, that is this, a solution containing non-volatile solute is directly proportional to the molality of the solution. So what is the symbol of molality here? We know molality is small. So what can write now? What you have learned? We find here that delta TB is proportional to A. So now we'll write here, rest of you know delta TB is equal to K into M. So what is K? K is the proportionality constant, but everywhere we are putting K only. So you will have confusion that K has come from where? It relates to what equation? So in that case, we write here KB. Okay, KB. So we'll write here where K B is the proportionality constant known as, we have a name, molar boiling point elevation constant or molar boiling point constant. Okay, or eubuloscopic can you see it properly? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Because light is not there. I'm
Yes, sir.
using light has gone. See, this one we have already learned. We know what is the value of M. So now we can write. We know M molarity is what? We know WB into what? 1000, then MB into what? WK. This is the value. Acha, now, wait. I want to define this one. Right. If M is equal to 1 molar solution, then delta TB is equal to KB and to M become what? Delta TB equal to, so now we can define what is called molar boiling point. Okay. So thus molar boiling point constant can be defined as the elevation in boiling point of 1 molar. See here, m is equal to 1. Kb into 1 only. So 1, so I need not write. 1 molar. Now what is 1 molar solution? Hmm? That is a solution containing 1 gram mole of non-volatile solute per 1,000 gram of. So this is the definition. Someone asks you what is Kb, then you can write the definition. We know M is equal to WB into 1,000 divided by MB into WA. Substituting the value of M in equation 1. We can write that delta dB dB to WA 1,000 divided by B. So this is our formula. And determine from this method also. So let me write down. Determination of molecular mass of solute by elevation in boiling point method. So I'll write this one again. Delta TB is equal to KB into WB into 1,000 divided by MB into WB. So now we'll go for cross multiplication. Therefore, MB is equal to KB WB into 1000 divided by delta TB into W. So this equation can be used to calculate. So by this method, you can determine the molecular mass of the unknown solute by making a, so first you measure the boiling point of the pure solvent, then you make a solution 1 molar solution, then you can find out the delta T, we can find out. All right. You determine the boiling point of the solution by the help of a thermometer. Okay. Now this KB you can find in a handbook. So you can substitute the KB. So the value of KB. Okay. So now we'll go for depression in freezing. Now what is a freezing? Okay. So freezing point is the temperature at which both the solid and the liquid state of a substance exist in equilibrium. Suppose you are freezing water at 0 degrees Celsius, you will find water is also in liquid state and also in the solid state. So that is called the freezing. Okay. So all of us, we know the freezing point of water is 0 degrees Celsius. All of us, right? We know it from very lower class also. Say in your house, you are staying in a cold place and too much of snowfall is there, and you want to go out. But snowfall has taken place within your campus and outside the campus also. You want to open the gate. Inside, you can remove the snow by taking the help of a shovel, okay, or spade. But outside the gate, if you cannot open it, then how will you go to the outside the gate? It's not possible. You cannot call your neighbor also. Then what we'll do? We'll take some salt and sprinkle on the snow. Within 5-10 minutes, you'll find the snow has melted. Mind it, when you have thrown salt, it was not a hot salt. You did not heat it. Its temperature is almost same that of the temperature of the snow, maybe little higher. Then why did the snow melt so fast? because moment you have sprinkled salt on snow, the salt has gone into solution. Moment it has gone into solution, the freezing point of the solution has decreased. Mind it, freezing point of pure water is 0 degree, but saline water is not 0 degree. See, you'll find even in the North Pole and South Pole where the temperature is -60, -70, entire amount of the water of the ocean does not freeze. Only the upper portion freezes, lower portion does not freeze. Why? Because the sea water contains not only common salt, various other minerals. So the depression of the melting point has become lowered. It is found that if you mix salt and ice powder, is you have to break it into small pieces. If you mix broken ice and the salt in the ratio of 3:1, that is, ice should be 3 parts and salt is 1 part. Temperature, freezing temperature decreases to -22. It's still -22. It will not freeze. It will not. So that is called the depression in freezing point. Okay. Now in depression in freezing point, which temperature is higher? The freezing point of the pure solvent. And which is lower? The lower is the freezing point of this solution. Okay. So let me write it again, same way. It has been experimentally found that depression of freezing point is directly proportional to the molality of the solution. Same thing that you have found in case of the elevation in volume. Okay. Then let me write here. Let TF0 and TF are the freezing point of your solvent and solution respectively. Okay? Where? TF0. See, water freezes what? 0 to Celsius. And I told you ice water mix salt and ice mixture freezes is what? -22. So which is higher? 0. So this will be higher. Where? This is higher than this is for solution. This is for pure solvent. Okay. So what we can write? Therefore, depression in freezing point is equal to delta TF is equal to what? Is equal to TF0 minus TF. So if you follow the experimental condition, what we can write? We can write that delta TF is proportional to F, or delta TF is equal to F. Where AF is equal to what? Proportionality constant known as molar freezing point depression constant. Or molar freezing point constant, or what? Cryo. Anything cooling is called cryo. Cryoscopic constant. So now, if M is equal to 1 molar solution, then delta TF, yes, delta TF, then DE equation delta TF is equal to KF into M becomes delta TF is equal to KF. So now we can define now. What is it? What is KF? Therefore, the molar freezing point depression constant can be defined as as the depression in freezing of 1 molar solution of a non-volatile solute. That is a solution containing 1 gram mole of a non-volatile solute in 1000 gram of solution.
So in the last line, it will be 100 gram of solvent. I mean, 1000
Correct.
or 1000
100
gram of
gram of,
solvent. 1000
please
gram of
correct.
solvent.
1000 gram of solvent because
Solvent.
it's a molar solution. 1000 gram of good girl. Okay, now we'll do like same thing. We'll do now. We know molar equal to what? WB 1000 divided by B into we write now that substituting the value of M in equation 1. We get what we write now here? Delta F equal to AF WB 1000 divided by mg. Then determination of molecular mass of solute. So that you know. So this is equation 2. So I just simply transfer it. I will not like the first one. I will not do again. MB is equal to what? AF WB 1000 divided by EF W. So this is equation. all these things are being done not for your exam purpose. Okay. So everywhere application is there. See, what is the application of the depression in freezing point? One application I told you. Suppose in future you go and settle, go to a new place like Canada and all these North European countries. In that case, if you find that too much of snowfall is there, even without asking your neighbor, also you can sprinkle some salt. Ice, snow is going to melt. But I see now many of our houses we are having car. It is not that everybody should have. And we also know that for cooling the car, we require coolant. A liquid substance is there which cools the car. So it is main solvent of this car, the coolant is water. But suppose it is very cold. Say, take the example, you have gone to Moscow. In Moscow, the capital of Russia, the normal temperature during winter is minus 30 degrees. If the weather is bad, it will go down. Same thing happens in Canada also. So in that case, your coolant will freeze. You can say that, sir, the temperature outside is very, very low. So in that case, my car will not get heated up. No, it will get heated up. Engine will get heated up. So how to keep that coolant in liquid state? For that, we use a substance called ethylene glycol. Is there in your book? Ethylene glycol. How does it look like? Now you know nomenclature. This is ethylene glycol. Is used as an antifreeze substance in car coolant. This may be asked later, so you have to remember. The last colligative property is called osmotic pressure. Osmotic pressure. So before knowing osmotic pressure, we should know osmosis. All of you know the definition of osmosis. Huh? So can you tell me what is the definition of osmosis? Who will tell? Don't keep quiet. If it is little wrong, then I'll correct it.
Movement of solvent.
Yes.
Movement of solvent.
Movement of solvent. The solvent can move in a beaker also. If I fill the beaker, the solvent will move from one side to another.
So movement of molecules. Movement of molecules.
Molecules, can you see?
No, sir.
Then you are correct only, but somehow the words are not proper. What should you write now? You write here. The spontaneous movement of solvent molecules from pure solvent to solution, or from lower concentration to higher concentration through a semi-permeable membrane. Short form we write SPM, which separates them. Is called osmosis. Now, what is semi-permeable membrane? These are porous membrane which allows only the solvent molecule pass through. Okay, you're right. I'll give you the example. You can find that is available in nature also, or it may be synthetic also. This is natural. Okay, natural SP. It is pig's bladder. Okay. Then a very old one, which people earlier used to use for writing. Parchment paper. Then cell wall. These are all natural semi-permeable membrane. Okay. Synthetic. Porcelain. There are some porcelain are there which are similar. Porcelain. Then cellophane paper. Cellophane. Have you seen cellophane paper?
No, sir.
No, sir.
Have you seen? Huh? No or yes?
No, sir.
Ah, very good. You are very intelligent. Hey, If you put gum in one side of the cellophane paper, is called sellotape. No, sir. Everything answer is no. Then potassium, copper, wait, is called the potassium ferrocyanide. No, it's called copper ferrocyanide. Copper ferrocyanide membrane. Cellophane দেখছস না? Cellophane you have seen. You'll find agarbatti. All these packets are sometimes coated with colorless or light yellow paper. Transparent paper. These are all cellophane. This osmosis. Okay, I'll show you an experiment. See here. Suppose I have my drawing is very bad. Don't lie. Okay, this is called YouTube, and this is the semi-permeable medium. SP. So here I have put. This is I have put here pure water, and here I have taken sugar. See, I have put both the arm is having the same height of the liquid. Then after some time, what you will find? You will find it has come down. See here, this is pure water. What has happened? Just done to this. And this is the sugar. So this the solvent molecule is going from pure solvent to the solution side. Or if I have taken, say it is a 5% sugar solution and it is 20% sugar solution, same thing will happen because this is dilute. From lower concentration, it will migrate to the higher concentration. So it will try to dilute, and it will continue till the concentration of both the solution does not become same. So, and this is a spontaneous process. So, do you write here now? Osmosis. What is osmotic pressure? See here, I want to stop the flow of the pure water from left arm to the right, but it is a spontaneous process. I cannot put up a notice here, no entry. Then how to stop? To stop the passage of the solvent, we don't want it should be. We don't want it to be like this. We want to stop osmosis. Okay. So in that case, what we'll do? Because water is flowing from this side to this side. So when it is flowing, any type of displacement involve force. So if I have to stop that displacement, then I have to apply a counter force. Okay, but here I cannot put my hand. So what I'll do? I'll exert some pressure from the top. Okay, and when I exert the pressure from top, I'll have a pressure. So pressure goes to all of you have seen. So when, and now we know because both the levels we can see. So when you have applied certain amount of pressure by which the movement of the solvent molecules from the pure solvent to the solution or from lower concentration to higher concentration stops, that is called osmotic pressure. So what should you, the definition? The pressure which is applied on the solution side to stop osmosis or flow of solvent molecules from pure solvent towards solution through semi permeable membrane is called osmotic pressure. See, for normal pressure, we put the symbol P, but osmotic pressure is a bit different types of pressure. It's not being exerted by the gas. So in that case, it is being given the symbol of pi. Is represented by pi. Now, it has been experimentally observed that osmotic pressure is directly proportional to the concentration of the solution. Means if you have put more sugar, more flow of the solvent will take place, and you have to apply more pressure to stop it. Because where from you know? Because you know pressure going. So we'll write now here pi is proportional to C. C is the concentration of second. Osmotic pressure is directly proportional. This I will write equation 1. Confusion na? To the absolute, forget it. That is phi is proportional to T. This is equation 2. Combining equation 1 and 2. You can write phi is proportional to C, or phi is equal to CR. What is R? R is the constant. Why do you put R? Why not K? Because we have found if we can put K, value of K is exactly equal to the gas constant R. Because of that, we put R. This is equation 3. Let me write here. What do concentration means? Concentration of a solution is equal to moles of solute divided by volume of the C. I can write down, put simple C is equal to N is the mole, V is the. So I can put this one in equation 3. Putting in equation 3, we can write pi is equal to N by V R. Equation 4. See, or what I can write, pi is equal to V N R T. Equation 5. See dear, is exactly like the gas equation. In gas equation, it was P, and here it is pi. Mind it, this equation seems to be very, very simple, but this equation has brought a Nobel Prize. The person who got first Nobel Prize in chemistry was von Hoff. He is the person who has proved that dilute solutions exactly behave like an ideal gas. So this is also known as von Hoff equation. Okay. All right. So I'll Now I'll write again here. What is N? Moles is equal to N. What is this? We know WB by MB. Putting this value in equation 4, we get pi is equal to WB by MB, V into R into, or pi is equal to WB R into T divided by MB into. See, from here we can calculate the molecular mass of solute. So, determination of molecular mass of, so I'll write now here MB, this is equation 6. MB is equal to what? Pi will go down. It will be WB R into T divided by pi into V. This is equation